P-N junction. A P-N junction is a boundary or interface between P-type and N-type semiconductors inside a single crystal of semiconductor. When P-type and N-type materials are placed in contact with each other, the junction behaves very differently than either type of material alone. We know that in an N-type semiconductor, the concentration of electrons is more compared to the concentration of holes. Similarly, in a P-type semiconductor, the concentration of holes is more than the concentration of electrons. Since the N-type region has a high electron concentration, electrons diffuse from the N-type side to the P-type side, leaving behind ionized donors on N side and combining with holes in P-type material. These ionized donors, positive charges, are immobile. Similarly, holes diffuse from the P-type side to the N-type side. When a hole diffuses from P to N, it leaves behind an ionized acceptor, negative charge, which is immobile. Combination of electrons and holes depletes the holes in P region and electrons in the N region near the junction. The space charge region on either side of the junction together is known as depletion region. The N material has lost electrons and P material has acquired electrons. The N material is thus positive relative to the P material. Since this potential tends to prevent the movement of electron from the N region into the P region, it is often called a barrier potential. This potential barrier must be overcome by an external voltage source to make the junction conduct. The formation of the junction and potential barrier happens during the manufacturing process. The magnitude of the potential barrier is a function of the materials used in manufacturing. Silicon p-n junctions have a higher potential barrier than germanium junctions.